Good morning, everyone. Welcome to the July Zoom Citrus Workshop. Thank you for joining us. First, I would like to thank Alison Walton from the Southwest Florida Research and Education Center in Mongi for her help and cooperation. Today's program offers 1 CEU for pesticide license renewal and 1 CEU for certified crop advisors. If you need CEUs, email me your name, email address, and license number. Our guest speaker this morning is Dr. Davie Kadyampakeni, Associate Professor in Soil, Water, and Ecosystem Sciences at the University of Florida Citrus Research and Education Center in Lake Alfred. The title of his presentation is Using Optimal Fertilization and Frequent Irrigation for Managing HLB-affected trees. In the July issue of the Citrus Industry magazine, Dr. Michael Rogers stated that the most important thing that can be done to improve productivity is to ensure trees are never lacking in water and proper nutrients. As you know, citrus greening bacteria damage and clog the phloem, which is the food conducting tissue. Then the translocation of food, which is sugars and nutrients, to the rest of the tree is restricted, and the tree declines and collapses due to food starvation. Nutritional therapy and optimum irrigation are important tools in the toolbox for managing HLB. Plant nutrition has been found to reduce the severity of citrus greening, to slow down tree decline, to increase the fruit yield, and to improve fruit quality. Proponents of plant nutrition consider optimal fertilization an effective means of stimulating the natural defense mechanism of plants. HLB-infected trees lose 30 to 70% of their roots. To minimize water stress and ensure optimum water availability in the root zone at all times, irrigation frequency needs to be increased and amounts of irrigation water decreased. Dr. Kadyampakeni presentation will include use of elevated micronutrients such as calcium and magnesium, use of elevated micronutrients such as zinc, boron, manganese, and iron, frequent irrigation, and use of soil moisture sensors. Dr. Kadyampakeni, it's all yours. Please go ahead.
All right, thank you so much, Mongi. And I'm glad you already touched the sweet spots for what I'll talk about. And I completely agree that in the toolbox for managing trees, I think no tree that's hungry will be responding to anything else we add to it. So any crop protection stuff and all that will only work if that tree is well fertilized and is also well watered. So as Dr. Zekri mentioned, I'll be talking about using optimal fertilization and frequent irrigation for managing HLB-affected trees. And I would like to emphasize that my talk will be covering most of the work we have done in mostly the past 5 to 6 years on nutrition. So we have a solid data set that we have confidence in. On the irrigation part, it's a couple of years, so we still have more work to do. But I think on the nutrition, we have some solid answers that might be used by growers at this point. So the key messages on nutrition include the fact that citrus fruit yields, juice quality, canopy size, and development are enhanced with a balanced nutrition approach for HLB-affected trees. And another key message is that root health and overall plant health and immunity are strengthened with elevated rates of macronutrients such as calcium, magnesium, and sulfur, and also micronutrients such as zinc, boron, and iron, and also manganese compared to current recommendations. And we have data to show it, and some of it is already going through the recommendation guidelines that we have for IFAS. Then the other key take message for nutrition is that use of disease mitigation and optimal nutrition work together, not in isolation. So what I'm trying to propose here is that if you're trying to add so many chemicals to the tree to improve its health, let's make sure that tree is well fed. Because that's why when you go to the doctor, they tell you, okay, you get this antibiotic, but make sure you take it with a meal. So that's also the same with plants. They need to have proper nutrition to be able to use those chemicals to defend themselves. Another thing that we have also learned is that with macronutrients and micronutrients, we observed reduced root dieback and increased root growth because root density was increased and the tree was more efficient in nutrient uptake. Another thing also we've learned is that nutrient leaching was significantly reduced with biweekly irrigation and retained nitrates in the top 6 inches. So this is another big deal for best management practices. And finally, it's that combined use of crop protection products and nutrition strategies remediate HLB-affected trees. So this is always where I start from, to say we look at the nutrient levels in a barrel, that we need to have all the nutrients at the right level. So the barrel here, right, is according to Justus von Liebig's law, the minimum, a professor from Germany, who determined that plant production is limited by a resource that's limited. So for example, if you don't have enough water, that will be a limiting resource. If you don't have enough of some nutrient, then that's a limiting resource. Or if you don't have enough light, that's a limiting resource. Or if you don't have the right temperature for growth, that's another limiting resource. So the scarce resource always restricts plant growth and therefore is called the limiting factor. So this is some little schematic that I always love to look at if I want to consider which factors. So the only way this can be optimal is when that place where you have the leakage of the barrel closed by everything being the optimum, then the tree will be responding to the best of its ability. So to begin with, I would like to start with an experiment we did on manganese on young trees, so 1 to 3 years old. So this is essentially for young trees. And we're looking at evaluating the response of Valencia on Kahoska rootstock to varying rates of manganese. And one thing we ordered was that we had a control with no additional manganese, but we optimized every nutrient. And then we changed the rates from the current rate of IFAS, 5.6 kilograms per hectare, or that's also close to about 5 pounds of manganese per acre. And then double that, which is like 10 pounds per acre. And then quadrupling the rate to somewhere around 20 pounds of manganese per acre. So this work we have already published in a journal of hot science, and I'm trying to work on an EDC publication that we can share with growers. So as you can see, we didn't see much differences in response over time between the manganese rates. And the only thing we noticed was that the tree heights increased over time. So we're taking measurements monthly, and we did this over 3 years. And then we also noticed that when we looked at the trunk diameter, that increased over time across all treatments in year 1. And then the rate that we found to be optimal in this case was about 10 pounds, as you can see the dark lines, 10 pounds of manganese per acre. That was the rate that was optimal. But one thing we noticed was that trees that got the current rate or recommendation, like at 1x, so about 5 pounds of manganese per acre, or greater than that, like at 4 times, that was a little bit higher and a little bit toxic for the less than 3-year-old trees. And interestingly, this is a result that you find a bit contrasting with the mature trees, because these are young trees. So for mature trees, we have a different ballgame, but this is for young trees. And the concentrations we found in the leaf were a little bit excessive. So we found that leaf manganese concentration was a little bit too high. So usually we would love to see this somewhere around
less than 150 parts per million. But here we are finding even numbers that are in thousands. So somehow, as you can see, the blue is the healthy trees, and HLB. The red or kind of the pinkish is those trees that are HLB affected. Yeah, so we find kind of a linear response of manganese to the different rates of manganese application, which was quite encouraging because we thought we'll find something like a curvilinear, which was showing a decline at higher levels. So the trees favored even higher levels of manganese application. So one thing that I would like to share here is that when we looked at the correlations of manganese with other nutrients in the soil, for example, boron, zinc, iron, and copper, we found a negative correlation of boron and zinc with manganese in the soil for both HLB and non-HLB plants. And then we found that for non-HLB plants, even the iron was negative correlation, but for HLB plants, there was a positive correlation of iron and copper with manganese. So somehow it means that that positive correlation with iron and copper, for example, and negative correlation to boron and zinc for the HLB trees shows that there's some kind of good synergy between manganese and boron and zinc compared to iron and copper. So iron and copper compete a little bit more with the manganese for uptake. And this is a dynamic that we always consider. That's why I always recommend having even foliar application of some of these micronutrients so that we can avoid those kinds of competitions in the soil. And then this is another part where we show the curvilinear relationship of the, when we looked at the biomass at the end of the study, we tried to destroy the plants and look at the biomass accumulation and also the trunk diameter. So as you can see in these curves, the sweet spots are somewhere between about 8, close to from 8 pounds to somewhere around 12 pounds of manganese per acre. That's why we find the optimal biomass. And then one thing we noticed is that the biomass for the non-HLB trees that we didn't have HLB inoculated or the pathogen inoculated had 5 to 50% greater biomass than the corresponding fertility level of the HLB trees. And then we also had another study that was looking at a mandarin. So similar study to the one we did for the Valencia orange, but this was now a mandarin called Bingo. It's one of the tolerant varieties to HLB. It does respond well. And we tried to evaluate different rates of iron. So we realized iron tends to confer better defense in the plant. So what we did was to look at varying rates of the iron at 0 current recombination UF-IFAS, like 5 pounds of iron per acre, and then 10 pounds of iron per acre, 2 times the rate of IFAS, and then about 20 pounds of iron per acre. So I put this in metric units, but those are the equivalent English units. So we did this for HLB trees, the ones that we inoculated, and then the non-HLB trees that we did inoculate with a pathogen that causes HLB. So my approach is for this busy table. But one thing I wanted to make sure you see is that when we analyze above ground parts of the plant, so for the HLB trees, and then the above ground parts of the plant for HLB trees, and the below ground, so the leaves, twigs, branches, and trunks, so for the above ground, and then the roots for the below ground, we found very strong correlations of the various nutrients with iron, especially for the above ground, even the below ground. For the healthy plants, as you can see in the roots, not much correlation in the roots with iron for all the nutrients, but a lot of correlation in the below ground, the roots, different root sizes for the the HLB plants in the different root categories. So what it means is that in general, the iron has strong correlations with all the starting nutrients for HLB-affected trees, meaning that you need, if you have optimal iron, then you also get optimal response of the other nutrients. I think that's how I look at it, because we found a very good response and no negative correlations.
And then we also looked at the biomass accumulation, like we did for the manganese. And what we found was that the above ground biomass varied between 33 to 44% greater than the below ground for corresponding ion fertilization. So a little bit greater above ground, which is expected, of course. But one thing I noticed was that we found that the 1 time to 2 times the current recommendation resulted in better biomass compared to the control and also the higher rates. So sorry, my rectangle there went a little bit. It moved when I was transitioning to this computer. I think this should have been not the control, but 5.6 to 11.2, which is the current recommendation, and then the 2 times the current recommendation. So something for the dry biomass. So the blue line is for the HLB trees. The red line is for the non-HLB, which is healthy trees. So we found that when you look at the HLB trees, the optimal rate for fertilization for iron for young trees seems to be a little bit close to the double the current recommendation. So close to about 9 pounds per acre to somewhere around 11 pounds per acre. So with those young plants, that's what we got. And then I want to share some information on what we got on some study that was supported by the Citrus Research and Development Foundation, where we looked at different fertilization rates. So a little bit higher doses, doubling magnesium, doubling calcium, doubling potassium. And then we also looked at the micronutrients. So particularly manganese, iron, boron, and zinc. And we either put those at the current rate, so 5.6 pounds per acre for the, 5 pounds per acre for iron, zinc, and manganese, and boron is about 1 pound per acre. That is the current recommendation. Then we either doubled that or quadrupled that. So we're trying to do this to look at the growth, the fruit yield, and juice quality, but also the root response. How did the roots respond to these varying rates? So I'd like to say that for this study, I'm just showing you about the foliar rates, but we had another comparative study where we had these micronutrients applied to the soil. So we got a little bit contrasting responses, but I realized for this talk, this would be good enough. And we've already published this work in Society of America, and I'm trying to see if we can also provide a highlight of these results. Some of these were already put in the Citrus Industry magazine article of 2021. So we have some highlights, especially of the results from the soil application of the micronutrients. So the major take-home message here is that when we looked at the changes in trunk diameters and all that, we didn't see much. So what we did was, since we're not seeing any differences in tree size, we looked at the percent growth or percent change in trunk diameters or cross-sectional areas over time. So as you can see here, so this S is the standard fertilization, so put everything in there. But now, since we're trying to increase the doses, so MA is the macronutrients and MI is the micronutrient, and then either we had the current recommendation of the macronutrient, where we have 1 MA, or 2 MA is where we doubled, and then 1 MI, 2 MI, 4 MI represent current recommendation of the micronutrients, or double, or then quadruple that the current recommendation. So one thing we noticed was that where we had doubled the macronutrients, so treatment 6 and 7, and then we doubled or quadrupled the micronutrients, we found a little bit of an increase in trunk size, about 6%. Very little, but quite significant. And then when we, because we had done this study on the, we had done this study on the ridge, so in Lake Alfred, and then we also had done this study on the southwest flatwoods in Clewiston, near Dunwoody. There's a block called Dunwoody, just north of Clewiston. Yeah, so another part here which we looked at was also the canopy volume. And since we did see differences between the canopy sizes, so we looked at the percent increase, because this was done over like 4 years. And then I only here I've compared data for 3 years. So we looked at the percent change from year 1 to year 2, or year 2 to year 3. And what we found was that there was no effect of the treatments on the canopy volume on the ridge side. So that's the top graph. And then on this southwest flatwoods, we found that there was a 15% increase for treatment 5 in the 3rd year of the study. So somehow treatment 5 is where we had doubled the macronutrients, but then we kept the micronutrients at the current recommendation. So somehow we didn't see similar results on both sides. So that's one thing I'm learning now, that we need to customize our recommendations by site. But we can't generalize because in the flatwoods, it's a poorly drained, on the ridge, it's well drained. So we might need to use a different set of guidelines for each site, depending on the soil type. And then in terms of canopy efficiency, where we looked at amount of yield obtained per volume of the canopy developed. So this was done over 3 years on the ridge side, on the top, and then for 2 years, because we missed the yield for 2020 on the southwest flatwoods because of COVID. Yeah, so one thing we noticed that we found significantly different canopy efficiencies in 2020 and 2021 on the ridge side. So somehow we find that there was a big difference, but the control, which is number 1, the first 3 graphs, or the first 2 graphs on the bottom, is the control, so number 1, and then the other ones are the treatments, as you can see on the right. Yeah, but we noticed that the treatments with the higher doses of the macronutrients were consistently high. But on the ridge, on the flatwood side, we didn't see much change over time. So somehow on the ridge, we found a better response, but on the flatwoods, we didn't see much change. So the better canopy efficiency was obtained where we had doubled the macronutrients and then kept the micronutrients at the current recommendation. So this is something that I'm talking about. Treatment 5 had a greater canopy efficiency on the ridge side. And then this is another part that I want to talk about. Several of these kinds of graphs, but I want just to share some information and the response we got in terms of root growth. So we had put rhizotones in the root area about 2 feet from the tree, and put them all the way to about 3 feet in the ground, but at a 45-degree angle. So at a slanting position, not like vertically. And then we're taking monthly root scans to see the root growth. So here I'm just giving you a highlight of the changes in root growth. And the funny part was that when we just started, we saw a big bump in the root growth in the control, not in the control, I mean in treatment number 6, where we had doubled the macronutrients and doubled the micronutrients. So you can see this graph. The controls consistently at the bottom. So that was the one part we noticed. So somehow all these other treatments, so either we doubled or quadrupled the micronutrients, and then doubled or used the current rate of macronutrients, we saw that bump throughout of increments in root growth. So this verbiage here is just trying to describe that. And we found the strongest response in treatments 5 and also 6 showing a greater root growth. And then you can see the positions of the changes in growth. So in spring, somewhere up to March, we see that kind of dampening in growth of the roots. And then somewhere around July is the lowest. And then somewhere around September, you start seeing the peak of the root flashes. So sometimes we try to optimize the fertilizer application to meet those root flashes to increase nutrient root uptake. And then we looked at the yields, and one thing we found was that because we didn't see much differences in the yield. And then what we did was to look at differences in yield over time. So 2020, 2019, 2020, 2021 for the ridge, and then 2019, we skipped 2020 because of COVID. We couldn't harvest because we're stopped from going there because of restrictions on how we can work in the field. And then we only harvested again 2021 and 2022, but I didn't add the 2022 data here, but they're comparable. So one thing we observed was that the increments in yield were greater in the control and treatment number 2, which had the macronutrients and the micronutrients of the current recommendation. And then the peak was treatment number 5. So this is the one that seems to be consistent on both sides. Treatment number 5, which had doubled the macronutrients and then used the current dose of micronutrients. So one thing we noticed is that though that increment in yield was just slightly 4% above 2021, I mean, compared to the previous on the ridge, but on the one thing we noticed was that we see a big increment in yield. So the yields were in the order of between 350 to 450 boxes per acre for those that would want numbers. But I didn't see differences. But when I looked at the percentage increment in yield, then that's where I found the catch of which one was better. So the treatment number 5 is the one that I would actually, I'm considering this to be expanded a little bit and tried further in commercial citrus crops, because we did this on the ridge in IFAS blocks, but Southwest Flatwoods, we did this on the at the southern citrus garden citrus. So they helped us with the block for this study. And that for those that want numbers in terms of bricks and soluble solids, we found the bricks to be somewhere around just in the range of 10, between 10 and 15 on the central ridge on the top level, and the ratios between 15 and 20 on the largely on the ridge, or as you can see on the right. On the bottom, on the left, you see the soluble solids for the flatwoods site. So slightly lower than the soluble solids we found on the ridge. So between 9 to 10. And then the bricks to acid ratio was between around 9 to somewhere around 12 for the flatwoods. But these numbers, I think, are a little bit better than what we have been seeing on the most of the industry numbers now. So the bricks being closer to about 10.5 or thereabouts, and the brick acid ratio being somewhere good also. Yeah, so I've realized that somehow with the levels of nutrition we are using, we are able to optimize the juice quality also. So at this point, I would like to give you highlights of 3-year data for a study we have done for about 6 years. So here I just have 3-year data because I couldn't have enough space to put all my slides here. But the trend has been consistent. So I'm hoping that some of the work I've already published will be used and will add into the IFAS guidelines. I shared some of these results in 2021 in the Citrus Industry magazine also. So you might find this also in the issue of September of 2021. We published in the Citrus Industry magazine article. But this has been also published in the referee journals. So in this study, we had looked at different rates of manganese, boron, and zinc, and we're using about 1 pound per acre of boron for the current rate of application, then about 10 pounds of manganese per acre for the IFAS recommendation, and we used about 5 pounds of zinc per acre for the IFAS guideline for the zinc. And then, of course, we were tweaking. We double when we use foliar. So, for example, this treatment number 1, that was the standard. So we put the standard rate. And then number 2, treatment number 2 here, we put some of the nutrients in the soil and some we applied. So that kind of doubling the rate. And then in treatment number 3, we had the soil application of the micronutrients, and then we doubled the foliar rate over the current recommendation. And then in the treatment number 4, we had double the current recommendation of the micronutrients. So nitrogen was applied at 3 rates, so about 150 pounds per acre, 200 pounds per acre, and then about 250 pounds per acre. So these are the equivalent metric units. So in a nutshell, in terms of canopy volume, we found that, as you can see here, in 2017, 2018, twice, and 2019 twice, and then in March 2020, the canopy volume was optimal at about 200 pounds per acre in each case. And we found this result to be consistent in 2021, 2022. We completed that study in 2022, and I'm trying to put those results together now to strengthen the our findings by publishing that. So we put this in a journal, referred here at the bottom in case some would love to read it further. And I'll put this also in an industry article or in the EDIS publication, so our growers can access also, and production managers. But one thing you also notice is that at the lower rate of nitrogen, 168 kilograms per hectare, which is equivalent to 150 pounds of nitrogen per acre, not much different to the current recommendation, especially in 2019 to 2020. So it's something very interesting. And you can see the control is the orange line in each case, and then the treatments are the soil application, the foliar application, and double the foliar application. And so soil application here, I put like terms 1, but it should be terms 2 because we doubled it. And the foliar application rates also had a current rate of application via soil. So I would like to say that the two foliar treatments had also a soil application of the micronutrients. Yeah, so one thing I've noticed is that except in 2017 to 2018, where the control also gave a better response at the current nitrogen rate, we found that in 2019 and 2020, we still consistently found that the response was optimized, especially at either at the lower nitrogen dose of 150 pounds per acre, or at the moderate one, which is the current recommendation of 200 pounds per acre. So this is a little bit of the information on the graphs that on the yield. So not much difference between the treatments and especially all the years, but you see that the yields were lower in 2019, but 2018 and 2020 were higher, and they've been high in 2021, 2022. But 2023 was a disaster because we had so much fruit drop. So one thing I would like to mention here, so these yields, we are putting there in kilograms per hectare, but these yields are comparable to somewhere around 350 to 450 boxes to the acre. Those were the numbers we obtained. So a lot of impacts of the what do you call this, alternate bearing from Valencia orbit. So you see in the 2019 yield a little bit lower, then 2018 and 2020 being comparable, but we also found 2021 being comparable, 2022 was a little bit lower, and then 2023 was a kind of very poor because we had so much fruit to the ground because of Hurricane Ian. And then this is another study that was conducted by Dr. Morgan and colleagues in Southwest Florida. They were looking at the impact of zinc, manganese, and boron applied separately at 4 rates, where the control got nothing. And then there was the 1.5, the current IFAS recommendation, then 3 times the current recommendation, and then 6 times the current recommendation. So one thing that I love from that study, and I love this graph because you see the canopy volumes. If you look at where you had where you had applied excessive nutrients, so the control is the one with the open circles, and then where you had the potassium nitrate applied with the micronutrients in the solid circles. So the canopy volume was optimized where you had the moderate, like about 3 times the micronutrients. And then yields is where the catch is. You can see when you go to about 6x of the current recommendation, the yields are decline. And then when you stay somewhere around 1.5x to 3x of the current recommendation, you get optimal yield. So then the key here is to keep manganese and zinc in the optimum or high range of the leaf nutrient concentration. That was the catch there. Similar study when they were looking at the zinc aspects. So you see the foliar zinc right in the tree, where you have the high levels of zinc. It's a little bit higher than current recommendation, above 100 parts per million of zinc. But the catch there also was that they got a better response of zinc at 3 times the current recommendation, and by keeping the zinc in the optimum to high range of leaf concentration. So this is something to think about when looking at the leaf results from the laboratory after analyzing for zinc. And here's something with the boron, but for boron, it seems we are going to about 3 times, you didn't see much response, or even 6 times. So somewhere around 1.5, the current recommendation is a little bit optimal for zinc, and that's where I think we want to stay, because we didn't see much response in canopy, but also not much response in yield. In terms of another study where we looked at the leaching of the nitrates, we looked at different levels of irrigation, and one thing we found was that when we irrigated using a Florida automated weather network information or irrigation scheduler, compared to infrequent irrigation, we realized that we improved nitrogen availability and reduced nitrate leaching. So you can see here on hamlins on either Cleopatra rootstock or hamlins and swing or rootstock at 3 depths, 6-inch depth, 12-inch depth, or at 18-inch depth, we found comparable or lower soil nitrate levels. So we published this work also in the a journal of water. Something here also, we found improved uptake of nitrogen when we optimized the rates. So look at 150 pounds, 200 pounds to 250 pounds of nitrogen. So these are equivalent metric units. And we found that we increase uptake of leaf concentration of N. But as you can see, Valencia on Swingo rootstock versus Valencia and Vocamerian rootstock, you see that the response on the Swingo is varied. Sometimes you get that peak in the nitrogen, especially in the summer flush. And then as you go the other seasons, you see a little bit of a dampening. For the Vocamerian, it favors very high rates of the nitrogen. So Vocamerian tends to favor the highest rate. As you can see, seeing a peak of the nitrogen over time. In terms of fruit yield, as you can see here, comparing different rates of nitrogen, Cleo in blue, and then Swingo, Strumero in orange. Yeah, so at the moderate rate of nitrogen, the recommendation, the middle graph, you see that the fruit yield is comparable. Cleo is highest at the current IFAS recommendation, and then Swingo is highest at the 250 pounds of nitrogen per acre. So something that to also think about when looking at the level of fertilization, because no such fits all. And then we had done we had also looked at the various levels of nitrogen and then various levels of macronutrients. So the calcium applied at about, as you can see at the bottom, calcium was applied at 40 pounds per acre. And then the manganese applied at 40 pounds per acre when applied alone. When you combine them, we put like about 22.5, 20 pounds and for both each calcium 20 pounds per acre and magnesium 20 pounds per acre in 2018, 2019, and 2020. And one thing we noticed was that the yields in terms of boxes per acre were consistent. So you can see here in 2018, the yields were varying between 86 to somewhere around 109 boxes per acre. And then in 2019, a little bit of a bump. So the yields got as high as 275 boxes per acre. And 2020, we also had another alternate bearing behavior, whereby we found also results that are compared to 2019. And we collected data in the next 2 years, 2021, 2022, but I just showed the first 3 years of this study. And this is another good resource at the bottom, 2021 Citrus Industry Magazine article. And then here I am also presenting similar trends, but I think I had this shared in a graph, but these are the results we got in the ridge, mostly getting used between 65 to somewhere around 300 boxes per acre in all the treatments, but better use obtained between 150 to 200 pounds of nitrogen per acre. In terms of root density, we also found that root density was increased by foliar nutrient application because of efficiency in soil nutrient uptake. So we kind of mobilize the nutrient uptake. So you can see here, I don't know if you can see the graph number B on the left at the bottom, a little bit of the key for the treatment. So calcium, magnesium, then a combination of calcium and magnesium, and then either foliar application of micronutrients or double the foliar application of micronutrients, and then the soil application of micronutrients, and then the untreated control UTC. A little bit comparable results, but one thing I noticed was that we're seeing a bump in the root growth, especially if you see on the graph number C on your top right, the most of the better responses were obtained with either elevated macronutrients or elevated micronutrients. And then the last portion of the studies I've been doing in nutrition, we looked at different fertilizer programs. So there was one where we looked at a program, a year of fertilizer called 9114, with all macronutrients elevated and included, and macronutrients elevated at higher proportions. Program 2 was where we had a growth standard, a 16-to-16 fertilizer, and then we were adding other nutrients except calcium and magnesium. Then on your right, you see that we're adding either we have regular acidity control, or we added acidity control, which was including other pesticides for controlling acidity, and then we added alliate to the soil, or added vellum prime to the soil, or added alliate and vellum to the soil. So one thing we noticed that we found a strong response with where we had alliate added to a fertilizer 9114, which had all the fertilizer blends, including all the alliate in it. And then the lowest was obtained where we had vellum and alliate added to the 9114 blend. Yeah, so, but funny enough, this was like 3 years in the study. Funny enough, more recently, we collected 5-year data. We found comparable root responses, actually, from treatment number 3 all the way to 8. And I'll show that in a moment, because we have the yield data also. And here also, you see in those treatments that I was talking about, treatments 1 to 8, we found bumps where we had added the crop protection products, though where we had the 9114 with all the sweet spots of the nutrients, where we had added all the other micronutrients, we found that we found a better response of the roots as well. So this graph shows the root growth in the top 8 inches, then between 16 to 35 centimeters, sorry, not inches, and then between 33 to about 51 centimeters, and then somewhere between 49 to 68 centimeters. And this was done in 2018, 2019, and 2020, and we continued until 2022. So one thing we noticed was that treatments with vellum or alliate had a consistent portion of deep roots. We had a lot of growth below 33 centimeters, which is about below 12 inches. So as you can see here, treatment number 4 all the way to 8 throughout. And then one thing also we noticed was that where we had the blend 9114, which includes all macro and micronutrients, showed deep roots also, especially in 2019. In terms of yield of the same study, as you can see here, a lot of variability. But one thing I want you to see is that after 5 years, we are seeing optimal response in terms of yield per tree, which is equivalent to about 180 to 350 boxes per acre, where we had added the blends with either vellum or alliate. So as you can see here, the last 3 graphs, 6, 7, 8, 6 includes the growth standard, with alliate and vellum. And then 7 is the Yara blend with alliate and vellum, and 8 is the growth standard with alliate and vellum. So somehow the take-home messages for nutrition are that the manganese and iron can be optimized as the double count recommendation, and that we can improve root growth and canopy size and use over time with elevated doses of micronutrients, and that we should consider revising and increasing current micronutrient doses for HLB-affected trees. And that we can also improve canopy size and juice quality and yield with improved macro and micronutrients. And then we can also observe like time for nutrients. We need some time to see a response of the the nutrients to fertilization. And then another take home is that biweekly fertigation kept nitrates in the top 6 inches. And also we have to aim at high or to optimum ranges of nutrients in the tissue to get better response. And combining fertilizer and crop protection products can also increase production in citrus trees affected by HLB. I would like to also go through a few slides just to talk about the level of irrigation that we need to optimize to get a better response of HLB trees. So one thing I would like to emphasize here is that we have tools available for irrigation management, including plant-based and soil-based sensors, and that optimal irrigation is possible using improved irrigation scheduling and can lead to greater water savings, and that most soils for crop production are sandy and voider and need good management to optimize water use, and that we need more studies on better irrigation management for bearing trees, because right now we have done most of this on the young trees because it was much easier to do, but we need to do better practices on bearing trees. So I'll start with this study where we compared the response of Valencia to different levels of irrigation on 540-foot long beds. So you see here, we were varying the irrigation rate based on the evapotranspiration of the plant. So this was done to determine the amount of water required to grow young trees at higher densities. And here are the densities, so varying from 181 trees per acre to somewhere around 363 trees to the acre. And here are the spacings. Excuse me. And one thing you notice here on your right, on your left, where we had used the 2% to 100% of the water requirement on top, you see that the water applications were proportional to the amount of water demanded by the tree. At the bottom, we had compared 25.6, 40, 53, and 81% of the water requirement of the tree. And that line on top is the amount of water required under output conditions. So you notice that all the amounts applied were depending on the amount of water that you had scheduled for the plant. So you can see here that the crop coefficients or the amounts of water the tree needs were responding, or they kind of correlating with the tree density. So the higher the density, the higher the coefficient. So this is something that we in IFAS are considering to look at to revise the irrigation rate, that for those that are moving towards higher densities, we might have to tweak the amount of water applied to match that plant water need. And something here, when you looked at the amount of water applied, so kind of deficits, the 2% versus 100, higher irrigation rate residing in soil moisture at or above field capacity. And then at the bottom, as you can see, stemwater potential, which is an indication of stress, shows negative values, but now it shows that there was less stress for higher irrigation. So where you had, the more negative it is, the more stress it is. So as you can see here, on the right, the rates at 53% or 1% of the evapotranspiration, less stress. And then where we had in 2018, where we had 62% versus 100% of the ETC, we did see a difference in stemwater potential. And finally, I would like to share another work that we did. Now, this was a little bit controlled in the greenhouse to look at the response of trees at either 80% evapotranspiration or 100%, and for trees that were either impacted with HLB or not. And these trees were Valencia trees on Kahaska rootstock. And we published some of this work with one of my previous postdocs in my lab. So one thing I would like you to take a look at here is we found that stormwater potential is significantly different between the months of collection. We did this over 3 years from 2019 to 2021, but I want you to look at especially 2020. So in 2020, excuse me, what we noticed was that here should have been 2.4, but somehow when I was editing, I ended up deleting that. So it should have been the water potential range from negative 2.4 to around 0.6. But in 2020, that's why we found a little bit of a stress of the water. But one thing I noticed is that we didn't see differences between the treatments for the same status. So for example, for HLB trees, at 80% or 100%, there was no difference. And for the heather trees, at 80% or 100% of irrigation, there was no difference. So that's something also to consider about. But there was a difference between HLB trees versus non-HLB trees. And then we also notice here that the HLB trees under both 80 to 100% had similar stormwater potentials for all, but of course, August 2019. Now, we also found that the water use peaked largely between 12 to 3 p.m., as you can see from these graphs. And also we found that trees that were stressed and irrigated at less than the current requirement at 80% evapotranspiration used about 30% more water than those irrigated at the current recommendation. And then we also found that in spring 2021, trees under the deficit irrigation of 80% had at least 28% greater subflow or water use under the improved irrigation of like at the current recommendation of 100% evapotranspiration for both trees that were impacted by HLB and those that were healthy. So in summary, I'd like to repeat what I said, that we have tools for irrigation management, especially the plant-based sensors and soil-based sensors, like sensors that we can use for irrigation scheduling. And then optimal irrigation is possible using improved irrigation scheduling and can lead to greater water savings, as you can see, where we had a field study of young trees with either 61% or 51% of ETC comparable, and even 81% ETC comparable with 100% ETC. And then for our center cells, we need to optimize water use to minimize nutrient leaching and also improve tree performance. And then we need more studies on better irrigation management for bearing trees. So at this point, I'd like to acknowledge my team members and my colleagues in Lake Alfred and also in other citrus research centers, and most of our sponsors and our fertilizer suppliers here. Would like to say thank you for all their support. And here are my contacts. And for those of you who would like to follow us on Facebook, because I posted quite a few things there. And this is my website, and this is my email. I'll be happy to take any questions if you have any, or any comments also. I'll be happy, or even send me an email. Thank you.
We've got 2 questions in the chat. The first, they're both from Marcio. The first one says, what source of calcium was used in these treatments?
Okay, so for the study we did in Clewiston and in some of our IFAS blocks, that calcium was from gypsum, so calcium sulfate. And then for the study we did, for the other study we're doing, the 5-year study I did with some support from Yara and Bayer, we used a blend that had calcium nitrate in it. So mostly those sources, those are the ones we used. And for the magnesium, something we are either magnesium sulfate or also magnesium nitrate. Thank you.
Thank you. And the second question is, how is the saline effect considered in those tests regarding the relationship of this saline effect to affect the availability and absorption of these nutrients?
Okay, let me see that question, because let me see. Okay, very good question. Yeah, very good question. I think we didn't worry so much about the salinity, but one thing we noticed in one of my blogs, we found that we elevated the pH quite a little bit. So your point is valuable. and we had to end up injecting some acid to lower the pH. So we had a pH going from about 6.5 to somewhere around 7.5. We had to inject some acids to lower it. So that's something that I did consider at the start of some of these studies, but eventually we had to consider that. In the Southwest Florida blocks, they ended up applying the calcium thiosulfate to lower the pH, and then some of the magnesium thiosulfate, so that they could lower the pH a little bit when they realized that they were having elevated salinity and also high pH. So very valid point.
Thank you.
You're welcome.
Any other
Another-
question or comment?
Go ahead.
Go ahead.
Yep, I was trying to say another question, so you said the same thing. Thanks.
Thank you.
It's all you, Mongi.
Any other question or comment? You can unmute yourself and speak up. Thank you, Dr. Kadyampakeni.
All right. Thank you so much,
Yeah,
Mongi, for having me.
Thank you all for your participation. Again, if you are interested in CEUs, please send me an email and include your name, your email address, and your license number. Since we don't have any more questions, thank you all for joining us and see you next time.
Thank
Thank you.
you.
Thank you. Thank you.
Thank you, Mongi.
Thank you, Davie.
Yeah.